Hello, welcome to today's class. Today, we will be solving questions on week 6 and week 7, which is binary compounds and naming of binary compounds. Now, before we start solving our questions, don't forget to hit down the subscribe button to subscribe to my channel. The first question is, identify at least 4 examples of binary compounds. So, because binary compounds has two types, which is the ionic compounds and the what? And the covalent compounds. I will give you examples of both ionic compounds and covalent compounds. So, for ionic compounds, now ionic compounds, they compose of what? Metals and non-metals. So examples of ionic compounds, we can talk of sodium chloride, we can talk of potassium oxide, we can talk of calcium chloride, NaCl, K2O, and CaCl2 for calcium chloride, potassium oxide, and sodium chloride. Now, don't forget, sodium is plus, chlorine is minus, then we get NaCl. Potassium is plus, oxygen is 2 minus, we get K2, then O. Calcium is 2 plus, chlorine is minus, then we get CaCl2. So these are examples of ionic compounds. Let me give you examples of covalent compounds, which consist of only non-metals. So we can talk of carbon monoxide, we can talk of carbon dioxide, we can talk of water, that is dihydrogen monoxide. So CO, we have CO2, we have H2O for dihydrogen monoxide. Now you can see CO and CO2. Now there's a difference between carbon monoxide and carbon dioxide. Now carbon dioxide is also called carbon 4 oxide. Why carbon 4 oxide? That is the oxidation state of carbon. So let's take for instance carbon. Now let's calculate for the oxidation state of, so we will calculate for the oxidation state of carbon. Now we have C plus, oxygen in this state is having a charge of -2. So oxygen multiplying 2, which is equal to, now this whole compound has no charge, so 0. So C minus oxygen charge is -2 multiplying 2, which is equal to 0. C minus 4 is equal to 0. C is equal to plus 4. So the plus 4 is telling you the oxidation state of carbon. So we can say carbon 4 oxide, which is the same as carbon dioxide. Now let's look at this CO. C plus O is equals to 0. C, oxygen in state is having a charge of -2 is equals to 0. C is equals to plus 2. So this is carbon, sorry, C is equals to plus 2. So this is carbon 2 oxide, which is telling you the oxidation state of carbon. So carbon 2 oxide or carbon monoxide. So when there is one oxygen atom, you say it is called mono. When it is two, it is di. When it is three, it's tri. Four is tetra, then so on. So this is carbon 2 oxide or carbon monoxide. Now let's look at the next question, which is we are to describe how magnesium oxide is formed. Now, how is magnesium oxide formed? Now, magnesium oxide is formed through a chemical reaction between magnesium and oxygen. Now, this process, magnesium will burn in air. So we are going to get so the processes which goes on before magnesium oxide will burn. There is what we call combustion. So magnesium would burn in oxygen, and there is an electron transfer. Then when there is completion of this electron transfer, there is what we call the ionic bonding, because when magnesium and oxygen they form a reaction, we are going to get what we call ionic bonds. So there is magnesium burning. So oxygen, so magnesium and oxygen. So magnesium will burn in oxygen to produce what we call, now magnesium will have to react with this oxygen. So there is magnesium and there is oxygen. So magnesium is having a charge of 2 plus because it is having an atomic number of 12. So our electronic configuration is 2, 8, 2. Oxygen is 1, 8. And the electronic configuration for oxygen is 2, 6. So 2 minus. Oxygen needs 2 more to be stable. Then magnesium will donate the 2. So there is what we call Mg2 plus and O2 minus. Since they are even numbers, 2, 2, we are going to cancel. So we are going to get what we call MgO. So when magnesium reacts with oxygen, you are going to get what you call magnesium oxide. Now you can see that this equation is not balanced, right? Now this is not balanced because the oxygen atoms present here is 2. The oxygen atoms present here is 1. Magnesium. So let me just show you how we are going to balance this. So there is magnesium here. Now, because there is a reaction, we call this the reactants, and we have what we call the product or products. The product. So there is magnesium here, there is oxygen here. So let me write the elements here, those which are reacting. So what you write for the left hand side, you write the same thing for the left hand side. So there is also magnesium, same here, and oxygen. So this one is here, and this is also here. So magnesium atoms present here, there is 1 magnesium here, there is 2 oxygen, there is 1 magnesium, there is 1 oxygen. Now there is 1 here, there is 1 here. This is already balanced. So let's balance these 2 and 1. So I can just multiply the oxygen here by 2 so that these 2 will be equal to this. So oxygen by 2. Now I'll have to write it at the back of magnesium so that it will affect oxygen here. So there is 2 magnesium here, then oxygen here is also 2, because the 2 here will multiply magnesium at the same time will multiply oxygen. So when magnesium becomes 2 here, I'll have to balance the magnesium here too. So I will say just times 2 so that this one also balance this magnesium. Simple like this, or you can just do it like this, plus O2 getting MgO. Just bring your half here so that 1 on 2 times 2 will cancel, then you get 1 oxygen, 1 oxygen. Something like this is also correct. So you're going to get magnesium oxide. Magnesium oxide. Question 3, we are to explain the role of electron transfer in the formation of binary ionic compounds. So what is the role of electron transfer? So electron transfer enables what? The formation of ions and opposite charges. When you talk about opposite charges, we have the positive charge called the cations, and the negative charge is called the what? Called the anion. So these are the what? The opposite charges. Now the opposite charges, which are then what? Attracted to each other, resulting in the formation of what? A stable ionic compound. Are you getting it? All right. Now let's move to the fourth question. So we have to write the chemical formula of one compound formed between each of the following elements. So the first element we'll talk about is magnesium and chlorine. So we have to what? Write the chemical formula for magnesium and chlorine. Magnesium and chlorine. So there is magnesium and chlorine. We have to write the chemical formula for magnesium and chlorine. So the first one is magnesium and chlorine. So when magnesium and chlorine react, what is the formula we are going to get? Now, you can talk about how you are going to name this, then you write the formula. So magnesium here, chlorine there. Now, this is actually an ionic compound, because ionic compounds, they normally consist of these metals and non-metals. So magnesium here is what? Is a metal, chlorine here is a non-metal. So magnesium on the periodic table is having atomic number 12, chlorine 17. So this is having electronic configuration of 282. This is 287. Now, magnesium will donate these two to become positive. Chlorine here needs one to become stable, right? So we are going to get what we call. So we are going to actually do what we call the exchange of valences. So magnesium here will be 2. So let me write it as chlorine and magnesium. So MgCl2. So this is magnesium chloride. Magnesium chloride. Then the next example is sodium and bromine. Sodium and bromine. Sodium and bromine. So Na and Br. So sodium is also a metal, bromine is for a non-metal. So sodium is having atomic number 11. So you're going to get 281. Now bromine here is having atomic number 35, and if we do the electronic configuration, we are going to get the last electron charge. Let me say 2, 8, 18, then 7. So it needs 1 to be stable. So we are going to get NaBr, which is called sodium bromide. So this is plus and this is minus. So you're going to get what we call sodium bromide. Sodium bromide. Don't forget, if you've forgotten how we did this, then you move back to our old video, our first video, then you learn how to do this. Now the last one is carbon and oxygen. Carbon and oxygen. Carbon and oxygen. Carbon, oxygen. So these can be likely examinable questions. So carbon and oxygen. So oxygen is how many? Having atomic number 8. Then carbon here is 6. So electronic configuration, we get 2, 4. Then we get 2, 6. Now, so 4 more to be stable, 4. This is 2 minus needs 2 to be stable. Now, the bond formed between carbon and oxygen is called covalent bond. So carbon here is a non-metal, oxygen here is also a non-metal. So there is covalent bonding here. So let me do the exchange so that we C and O. Now 4 here, there is 2 here. Now we can actually do some cancellation, right? We can do some cancellations. So you let me do it here. So 4 and 2, you are going to get 2 here, you are going to get 1 here. So these 2 will come here, this one will come here. So you're going to get CO2, which is carbon dioxide or carbon 4 oxide, as I explained earlier. Now, question 4. Question, is it question? No, question 5. Sorry, question 5. Compare a compound. We have to compare a compound formed between sodium and chlorine. So we have to compare a compound formed between sodium and chlorine. So first one is 1. Sodium and chlorine. So we have to compare a compound formed between sodium and chlorine, and one formed between hydrogen and nitrogen. So the II is hydrogen and nitrogen. So we have to compare a compound formed between one, which is sodium and chlorine, then the next one is hydrogen and nitrogen. And we are going to use this information to answer questions, 3 questions. And the first question is, we have to write down the name of this compound. You have to write down the names of these compound. So the first one is sodium and chlorine. Now we did a sample question on sodium and chlorine. And sodium and chlorine, they will form what we call the sodium chloride. So we will say A, sodium chloride. So that's the name, sodium chloride. Then we are going to get hydrogen and nitrogen is ammonia. We are going to get ammonia. So let's do it and see. Let's do it. Hydrogen and nitrogen. So hydrogen, nitrogen. Hydrogen is 1. Nitrogen is how many? 7. So electronic configuration, you're going to get 1. Here we are going to get 2, 5 like this, which is 7. Now nitrogen needs how many to be 7? Needs 3. Then hydrogen here needs 1. So plus like this. So we are going to do our exchange. So hydrogen, nitrogen like this. So there is 1, then this 3 comes here. So we are going to get NH3 like this, NH3, which is, so this is NaCl, this is NH3, also known as ammonia or nitrogen trihydride. Nitrogen trihydride. So these are the names of these compounds. So one formed between sodium and chlorine, and one formed between hydrogen and nitrogen. Normally, we will have to mention this nitrogen before this hydrogen. So, or this nitrogen should come first, and hydrogen should go there. So nitrogen, and this there is a question that I don't want to talk about it. Now the next question is, we have to write the chemical formula for each compound. So these are the chemical formulas for the compound. So these are the chemical formula for these compound. And the last question is, we are to identify the type of bond. So what type of bond is formed between sodium and chlorine, then hydrogen and nitrogen? So the type of bond formed between sodium and chlorine is called what? An ionic bond. Why? Because ionic bonds, they contain metals and non-metals. And the type of bond is called covalent bond. Covalent bond. Covalent bond. Because these two are all non-metals. And the last question is, we are to state the differences between the type of bond formed between these. We have to state it. Now, this means we will have to state the difference between between ionic bond and covalent bond. Now, you are to answer the last question for me. Now, you leave a comment. You can write your answers at the comment, or you send it to me privately. I will check for you. So, the difference between ionic bond and covalent bond. Please don't forget to subscribe to my channel. See you in my next video.